Specific heat capacity, also known as thermal inertia, is the amount of energy needed to raise 1 gram of a substance 1 degree Celsius. It is a property of matter, and therefore it varies based on what kind of matter you're dealing with or what kind of substance. In the case of this experiment, aluminum has a much lower specific heat capacity than water, so it will change much more rapidly than water would.
Thermal equilibrium occurs when two or more objects come into contact and heat is transferred from the warmer objects to the colder objects until all objects in a system reach the same temperature, called thermal equilibrium. The law of conservation of energy is present in this lab because thermal energy is the same before and after heat is transferred.
There was 3,976.64 calories transferred from the hot water to the cold water through the aluminum cup, and we got this by using the equation Q equals mc delta T.
We determined that 1,437.86 calories were transferred from hot water and the cup into the cold water. We determined this by using the equation Q equals mc delta T.
The equation Q equals mc delta T was used once again to calculate the amount of heat transfer to and by the aluminum cup. Prior to the hot water being added to the system, the aluminum cup had already begun heat transfer with the cold water by adding heat to the cold water because it was initially at a higher temperature. Once the hot water was added, heat was transferred from the water to the cup, and it was calculated to be about 180.994 calories of heat transferred total. In conclusion, physics concepts such as thermal equilibrium and specific heat capacity were exhibited in this lab. Thermal equilibrium was shown when the hot water, the cold water, and the aluminum cup of all different temperatures were put together and reached thermal equilibrium, the same temperature at 39 degrees. Specific heat capacity was shown because, as the data showed, the water took much more energy to change temperature than the aluminum cup did.
The sources of error in this experiment was the thermal energy lost through the air and the wooden ring.